So now we need to make the jump to probability. When we're talking about probability, we're going to be trying to count things. And what we have to do is we have to ensure that our sample spaces have equally likely outcomes. So when we're talking about a die, a 1 is just as likely as a 2, as a 3, a 4, a 5, or a 6. If we're talking about tossing a coin, say we toss one coin, heads and tails have to be equally likely. If they're not, we can't use the definition below. Let S be a sample space of equally likely outcomes, and let E be a subset of S. Then the probability that event E occurs, denoted by P of E, is the ratio or division of the number of things in E divided by the number of things in the sample space. So what we're basically doing is counting how many outcomes there are in E and taking that as a portion of the total number of things in the sample space. So suppose a single die is rolled so that the sample space is 1, 2, 3, 4, 5, 6. What is the probability that a number less than 3 is rolled? A number less than 3 is rolled is the event E being 1 and 2. So to figure out the probability, I need to go ahead and count up the number of things in that event and divide it by the number of things in the sample space. So in this case, that would be 2 divided by 6, or 1/3. So 2 of the 6 possible outcomes in the sample space are accounted for this event, so it's going to happen 1/3 of the time. Suppose a playing card is chosen at random from a standard deck. We choose this out. We don't know what's going to come out. It's going to be a random occurrence. And what we want to know is what is the probability that a king is chosen. So in our case, there are 4 kings in the 52 card deck. So when I ask for the probability of a king, I want to know the number of kings divided by the number of things in the sample space, or 4 divided by 52, and that reduces to 1/13. Now I could also ask, what is the probability that a diamond is chosen? So now I need to know how many diamonds there are. So there are 13 diamonds in a 52 card deck. The probability of a diamond is going to be the number of diamonds divided by the number of things in the sample space. So 13 divided by 52, or 1 divided by 4, or you'll get a diamond 1/4 of the time. So now let's figure out, what is the probability that a red face card is chosen? To do this, we need to know how many red face cards there are. And there are 6 red face cards in the 52 card deck: the king, queen, jack of hearts, the king, queen, jack of diamonds. So the probability of red face card is the number of red face cards, which is 6, divided by the number of cards in the sample space, which is 52. So that 652 reduces to 326. What you'll notice about all of these is that for any of these events, the probability that I'm getting is between 0 and 1, including 0 and 1. So probability being 0 would mean that the event is not going to occur. That would be the probability of the impossible event. Probability being 1 is it's certainly going to occur. That would be the probability of the certain event. To go beyond what we've been talking about, sometimes when we're given statistics, we can go ahead and also figure out probability based on those statistics, doing this kind of idea of the relative number, or the relatively how often something would occur. The table below gives the number of years of service of senators in the 108th Congress of the U.S. So we've got years of service in one column, numbers of senators in the other, and there are 50 senators with 0 to 9 years of service, 29 with 10 to 19, 14 with 20 to 29, 4 with 30 to 39, and then we've got 3 old geezers with 40 or more years of service. So what we want to know is find the probability that a randomly selected senator serve 30 to 39 years. So I want to find that probability, so I have to count up how many senators there are. that have 30 to 39 years of service and then divide that by the number of things in the sample space or the number of senators. So the number of senators with 30 to 39 years of experience is 4. There's 100 members of the Senate, so 4 over 100, or 0.04, is the probability. That's not very likely. That's fairly close to 0. But what you'll notice here is this wasn't like the previous problems where we could list out everything and then I could go ahead and essentially figure out, relatively speaking, what goes on. This is more like a statistical thing, that in another Congress I could get different numbers here and then I'd get a different probability here. Before, if we're rolling dice, we're going to get exactly the same probability for rolling a 5 as we do 3 days down the road. This is what we would call empirical probability in this case.